Hello friends, welcome to Kion Lab. Today we are going to discuss data models in database management system. Data models, to represent the data, we need certain conceptual models that could describe data, data relationship, data semantics and data constraint. So there are some models available depending on what type of data available and how do you want to represent it. So there are four types of different data models available. One is the relational model, then entity relationship data model, object based data model and semi-structured data model. So first we are going to see relational data model. Relational data model is a collection of tables. It is the collection of tables Now relational data model, when it is required, or what are these tables? So when you are going to design a system, database system, first of all try to find out the entity amongst it. Entity represents, these are nothing but the objects, and these entities can be identified by its attributes. So in a system there can be multiple entities. Because everything we cannot put into a single file or single table, because when we are trying to retrieve any particular information, the whole records get retrieved from the database, which was the drawback of flat file system. So that's what in database management system we are going to categorize, or we are going to make the entities separate and put them into table. Just like we have discussed the university system we would like to develop. So when we are talking about university, what are the entities comes into the picture? We have courses, we have departments, students, then building, then professor, or we called it as a instructor. Then all these entity are identified its attribute. Courses, we can have how it is this course is going to identified. It can have course ID, course name, duration and department. So the course and department, how we are going to relate in the course and department, we could have some common entity, that is a course name. The department is conducting which course, so we can found the relationship amongst these two entities, and that's what it is called as the relational model. We can see the example over here. You can have this relation. Now relation, you can observe here the attributes are nothing but the columns. So any relation, now here the instructor table you can found out, and all these are the attributes, ID, name, all these are attributes, and instructor is the entity. So and these are the record, different records. So you can take any row, it is called as the tuple, or it can be called as a record of a instructor. So it can identified, the instructor is identified by its attribute, that is ID, name, department name and salary. So this is a relational model. Now you can found out your department name and instructor. So there is department name is a common department name is the common attribute amongst these two tables which can relate these two entities, instructor and department, and it could become the relational model. And this model, this conceptual tool, allows us to model these entities into the format, and to make it to put it into that format, certain rules and certain definitions are there that we are supposed to learn. Second model, entity relationship model. So as we have already discussed, these are the models. An enterprise is a collection of entities and relationship. So it can be a pictorial representation, that is diagrammatically it can be represented. In relational model, it is represented in tabular format, and here it can be represented in terms of diagram or pictorial representation. So instructor, that is the entity, is represented in the rectangular box, and these are the its attributes identified the instructor. So similarly here, this is the entity department and these are its attribute. This attribute identified the department, and the relation between these two entities can be found out this relation named as the member. So instructor is the member of the department, or department have this particular instructor. So now depending on this, in the coming slides, in the next video, we are going to see the its mapping also. The next model is object based data model. Now object based data model is object relational data model. It is a flat atomic value and object relational data model. Now atomic value, you are already knowing, that is, if we are doing the fund transfer, it could be a complete or not complete, means you should have only one value here. Suppose you have a name, means you could have only a name. But in object relational mapping, you can have first name, last name, like this. Name can be multiple copies, first name and last name, it allows. So it is going to violate the property of 1NF, which is not allowed. That is, we are going to see in the future video. So object relational data model, it is basically used by object oriented programming language such as C++, Java or C#. It is nothing but the extended ER model. It is the extended ER model with notion of encapsulation, functions and object identity. Encapsulation, functions and object identity. It is going to further use the features of object oriented programming language. It is the combination of earlier two models. It is the combination of relational model and object oriented data model. We can have the example here how this concept of object oriented programming has been used. Now here I'm going to write a query for you. Create, it is the structure type inheritance. Structure type inheritance. Structure type inheritance. So here you can understood this concept, how it has been used. I will write here, I will write the SQL query, structured query language. Create type name as first name, varchar data type 20, last name, varchar. Here I am not creating a table, I am creating a type, because in this object relational model we would like to extend the feature of this ER model. 20 and final. So we'll stop here. If you don't want to stop, you can write no final. Now when you are creating a table, how it has been used: create table person name of type name. Now here your data type is this name. This is the name. Inheritance, we are trying to access the inheritance. Now how it is been used? So you're using name dot this attribute name dot fname to fetch the data from the database. So this is object relational data model. Now the last model is semi-structured data model, and its example is XML, extended markup language. Now this is extended markup language. Here if you are having little bit knowledge about HTML, hypertext markup language, there you can find out the fixed tags or predefined tags to represent the language. Here you can have user defined tags, so it is been called as the semi-structured. Semi-structured data model permits the specification of data where individual data items of the same type may have different set of attributes, and it will be represented something like this. It is not having the fixed tags. So you can see the example over here. Suppose you would like to represent department, so you have, this is user defined tag department. It can have subtags department name. Here I will write biology data. This is a data. This is the tag it represented. When you run this, you will find out this is the output biology, and this is my closing tag department number. So whatever you are using here, starting tag, the same with the backslash department name. Similarly you can have many more user defined. These are not the predefined. Building Watson and building, and ending tag of department. This is the example of semi-structured data model. So we summarize our today's session, that is the 4 data models we have studied. Relational data model, this is based on collection of tables. Second model we have studied entity relationship model. It is based on the pictorial representation of relational model. Next one, object relational data model. Object relational data model, which is extended ER model with the features of extended ER model with the features of object oriented programming. And the last one, semi-structured data model. Data model. So here you have user defined tags and the example is XML. So thank you.